Hello, 7th graders. I have entitled this video, Combining Like Terms Continued. In a previous video, I went through the fact that 2x times 3x and 2x plus 3x are different animals. One of the most important things to realize early on in learning algebra or pre-algebra in 7th grade is that adding and multiplying are completely different operations. Whole different set of rules for the two. We're going to focus here, as we did at the end of the previous video, we're going to focus here on addition. What we're doing in this video is frequently called combining like terms. That word combining is addition, subtraction. We could technically just say adding like terms, because as you look up here and you see, for example, a minus 3 here, you know that subtracting 3 is the same as adding negative 3. So everything we're doing up here could be seen as addition. But we have this strong tradition in middle school math in the textbooks to refer to it as combining like terms, but it's adding. And what is it we're being asked to do? It's a one-word direction, simplify. And there are many different kinds of simplifying in math. We can simplify a fraction. We can say that 6/8 is equal to 3/4. We have simplified or reduced the 6/8 to 3/4. This kind of simplifying has to do with how many terms we have. In mathematics, the term, it's a vocabulary term, and it is term. And what it means is things that are added or subtracted. And you can count them. Up here we have 4 expressions. The word expression is about as broad as you can imagine in math. An expression is anything that contains numbers, letters standing for numbers, operations, add, subtract, multiply, divide, exponents. But what you don't have in an expression is an equal sign. You don't have an equation to solve. And you're familiar with those, of course. If we have an equation like 2x plus 3 equals 7, we solve this as again x equals 2. 2 is the only number we can put where this x is to get a true statement. But notice we have no equal signs in these expressions. We're not going to be able to learn what a is in any of them because we're not told what this expression is equal to. If I put over here equals some number, like up here equals 17, then we could determine what the a has to be. But that's not what we're doing here. We're simplifying a 4-term expression, and we're going to get it down to 2 terms. 2 terms is simpler than 4 terms, and so that's why we have that instruction, that direction, to simplify. Now, through the ages, I have to say this, it's sort of mandatory for any math teacher at some point to say that we cannot add apples with oranges. You can only add apples with apples, oranges with oranges. Now, some bright and sort of pesky student might raise his or her hand at this point and say, oh, Mr. LaBeouf, if we are adding 2 apples and 3 oranges, don't we have 5 pieces of fruit? Well, okay, I'll give you that when you're dealing with fruit. So the analogy is not perfect. But if we're trying to add 2x and 3y, as we saw in the previous video, there's no general thing like the word fruit that we could use. 2x plus 3y. You cannot say it's 5 letters or 5 of anything. It just doesn't work because there's no common factor in these 2 terms. This cannot be simplified. This 2-term expression cannot be simplified. You could rewrite it as 3y plus 2x, the commutative property of addition, but it's still 2 terms, so you have not simplified. You can only add apples with apples and oranges with oranges. And in math, you can only add a terms with a terms. B terms with B terms, X terms with X terms, Y terms with Y terms. Number terms, like pure number terms, of course, can be added as we always have. I'm not going to rearrange these terms. I've intentionally alternated, an A term, a number term, an A term, a number term. I've done that on purpose to get you into the habit of when you see it like that, you can mentally rearrange so that it's okay to add the 5A and the 2A. Addition is commutative and associative. If you're asked to add a bunch of numbers, and remember, this is all addition, even though you see these minus signs, you could think of this there being a little plus sign, plus -7. So it's all addition. We call it combining, but it's all addition. And you can do it any way you want. So you can mentally combine the like terms. What do you think the first one comes out to be? Add the 2A terms, add the 2 number terms. 7A plus 10, right? Isn't this easy? This is incredibly easy. 7A plus 10. Now let's take care of this right from the start. It is just as important in math to know what you cannot do as it is to know what you can do and should be able to do. Don't do too much. Don't do something that's wrong. 7A plus 10 is not 17A. You cannot simplify 7A plus 10. You could rewrite it as 10 plus 7A, but that's not simpler because it's still 2 terms. Why is 7A plus 10 not 17A? Well, I could say because you just tried to add apples with oranges. You tried to add an A term with a number term, and you cannot do that. It's a violation. But here's something better for me to say. Let's choose a number kind of arbitrarily because of all the numbers that exist. There's only one number that I can't choose right now to make my point. And I'll show you what that number is in a moment. But I'm sure that I could choose the number 4 for A. So let's say A equals 4. And let's see what happens when you put a 4 in for A in the 7A plus 10. Well, that, of course, is 38. 7 times 4 is 28, plus 10 is 38. So when A is 4, this is 38. But putting the same 4 here for the A here, 17 times 4 is 68. And 38, the last time I checked, is not the same as 68. We have just proven that 7A plus 10 is not equal to 17A because it doesn't work for 4. And it doesn't work for any number except for 1, which I'll show you in a moment. Okay? Now, I've kind of done things a little bit backwards here. I've immediately jumped to the fact that 7A plus 10 is not 17A. But let's take that same 4, and let's go back to the original expression and put a 4 in for A here, and a 4 in for A here. And now let's get rid of that 17A, because 7A plus 10 is not 17A. So let's just banish that from our minds right now. We're going to put a 4 in for each A. The one here, and the one on the right side like that. Well, here we get, of course, 20 plus 7 plus 8. 5 times 4 is 20, 2 times 4 is 8, plus 3. And here, like before, we got 38. 38. 7 times 4 plus 10, 38. So let's add. 20 plus 7 is 27, plus 8 is 35, plus 3 is 38. That's a true statement. And in fact, you could stay here until the end of time, choosing a number to put here where this A is, this A is, and this A is. And the left side will always equal the right side. 7A plus 10 is always equal to 5A plus 7 plus 2A plus 3. It's known as an identity. True for all numbers. The two values are identical for any A whatsoever. Now, to sort of emphasize the difference between simplifying and solving an equation, and also to review some things that you did quite successfully in 6th grade. Let's go back to that 7a plus 10, which does not equal 17a, but let's just say for a moment that it does. Okay? Let's say for a moment that 7a plus 10 equals 17a. It does not, the two are not equal for all a's. That's why we had to stop at the 7a plus 10 up here. Because this was just an expression we were trying to simplify. We had to stop at 7a plus 10. But let's say we're given this. This is a totally different situation now. Totally different thing you're being asked to do. You're being asked to find the number you can put where this a is and that a is to get a true statement. It's pretty easy, isn't it, to figure out what that a has to be? It's 1, right? And if you couldn't immediately see that, your training has taught you that you would subtract 7a from each side. These cancel to 0 here. Then you have 10 on the left equals 17a minus 7a. Now there's combining like terms. Within the context of solving that equation, we have to be able to combine the like terms. Subtract 17a minus 7a is, of course, 10a. And then our final step would be to divide each side by 10 and get a equals 1. Please understand the difference. We can, when we're simplifying originally and getting 7a plus 10, we cannot say that's equal to 17a because it isn't, except when a is 1. But if we're simplifying something, we're trying to get expressions that are true for all numbers. Okay? Please understand this difference. It's crucial. It's just two totally different things that we're being asked to do. All right? So let's move on. We won't solve any more equations in this video. We'll just quickly finish the rest of the expressions, simplifying them. And the way I've chosen these expressions, all 4 of them begin with 4 terms and can be simplified down to 2. You won't always be simplifying from 4 terms to 2, but that's how all of these work. Right? So you figure out what you think the second one will simplify to. Number 1, simplified to 7a plus 10. Number 2, well, we could look at 5a minus 2a. We don't have to rewrite and put them together. We can do that mentally. That's 3a. 5a minus 2a is 3a. And then we focus on the numbers. We see a 7 and a negative 3. 7 minus 3 is 4. So the second one simplifies to 3a plus 4. And once again, that's not 7a, right? 3a plus 4 is not equal to 7a, except when a is 1, just similar to before. But we're not being told that 3a plus 4 is equal to 7a and being asked to come up with that 1. We're just being asked to simplify here. No matter what this a, and this a is, the left side will always be equal to the right side. They are an identity. That is an identity, with the left side being equal to the right side for all values of a. We could stay here forever choosing an a here, here, and here, and the left side will always be equal to the right side. That's the whole point. Now the third one, negative 5a plus 2a is negative 3a, right? Negative 5a plus 2a is negative 3a, and negative 7 minus 3 is negative 10. I hope you realize, ladies and gentlemen, combining like terms piggybacks on or continues from where combining integers leaves off. If you know that negative 5 plus 2 is negative 3, then you know that negative 5a plus 2a is negative 3a. No surprises. If you were going to guess at what it would be, before I ever introduced you to something like negative 5a plus 2a. If you were to guess at it, I bet a lot of you would guess that it's 3a, negative 3a, and you'd be correct. And the final one, we've got negative 5a minus 2a. That's negative 7a. And negative 7 plus 3, of course, is negative 4. So there you go. I tried to choose 4 that had variety to them. None of the terms, like, all the A terms are different in the answers. 7a, 3a, negative 3a, negative 7a, and a 10, a 4, a negative 10, and a negative 4. I did that on purpose to show the variety of how these expressions can come to us. And you gotta know that negative 5a plus 2a is negative 3a, but negative 5a minus 2a is negative 7a. You have to understand that distinction, which of course goes back to when you learned adding integers in 6th grade. So I'm going to put 4 more expressions up here that are going to work in a very similar way. And here we are again. The only difference here is that there are no pure number terms. In each of these 4 expressions, we have 4 terms. And 2 of them are x terms, and 2 of them are y terms. So we can combine or add the x terms, and combine or add the y terms. It works in a very similar way as the previous 4. And I just want to make this point that sometimes as you go through your algebra lives, your math lives, you might get the x terms right next to each other and the y terms right next to each other. They won't always be separated like this. I just do that to add a little bit of extra level of complexity. It's really not that much more complex, but just to make sure you're paying attention. You don't just go left to right. You just don't try to do 6x minus y. You are combining x terms with x terms and y terms with y terms. So what about that first one? What do you think? You should be able to do all of these now. Isn't the first one 4x plus 2y? 4x plus 2y? Okay, now here is a little something that could be troublesome. You see those red ones that I put there, whether it was plus y or minus y? This minus y I can think of as minus 1y, and the y that was there originally can be thought of as plus 1y and plus 1y. Now when did you learn that 1y is the same as y? 3rd grade or earlier, right? And last year I taught you, in 6th grade I taught you that negative y is the same as negative 1 times y. It's a very sort of logical thing, but I actually proved to you why multiplying a number by negative 1 is the same as taking its opposite. There's a beautiful proof of that, which I'll probably show you again this school year, but for now we'll just accept the fact. Now, you're almost never going to see those red ones there, but keep in mind that you have to think of them that way in order to do the simplification. So now let me make this realistic again and remove those ones, which you will hardly ever see. Why do you never see them? Why should you put them? Why should you put plus 1y? Mathematicians like to have as little bit of symbolism as possible. Mathematicians like things to be simple, so we just agree that y, instead of writing 1y, we write y because they're always the same. They're always equal. Before we move on to the 2, 3, and 4, let's say something similar to what we did earlier. This is not 6xy or anything else. Notice the not equal to sign there. 4x plus 2y cannot be simplified. You could rewrite it as 2y plus 4x, but you're never going to be able to get that expression down to one term. because you've got an x term and a y term. You cannot add x's with y's. You cannot add apples and oranges. All right. Once again, we could easily prove by taking, let's take 4 again, 4 for x and 5 for y. So let's say x equals 4, y equals 5. Well, this thing up here, which is not the same as 4x plus 2y. 6 times x times y, 6 times 4 times 5 would be 120. Right? 6 times 4 is 24, times 5 is 120. Down here, if x were 4, this would be 16, 4 times 4 plus 2 times y is 5, 2 times 5 is 10, 26. They're not even close. Right? They're not even close. So, in a similar way to the last time, just by choosing a value of x, we see that 4x plus 2y is not the same as 6xy when x is 4 and y is 5. And so just in general, they're not the same. When we took this original expression and said it equals 4x plus 2y, what we mean is, no matter what x and y are, no matter what this x, these x's here, and these y's here, no matter what they are, and, if this x is the same and this y is the same as these two and these two, then 4x plus 2y will always be the same, no matter what the x and y are. That's what's meant, what's known as an identity. So let's kind of quickly go through the other three as soon as we actually realize that, again, I kind of did this sort of backwards. That's 4x plus 2y. Let's just show 4. Let's take the same. X is 4. Y is 5. Right? Y is 5. X is 4. Y is 5. When we did this before, we got what? 16 plus 10, 26. When x is 4 and y is 5, 4x plus 2y is 16 plus 10 or 26. So now let's go through these 4 terms. If x is 4, 6 times 4 is 24, and then minus 5, y is 5, so it's minus 5, and then negative 2 times 4 is negative 8, the x is 4, remember, and y being 5, we have 3y, so that's 15, 3 times 5. 24 minus 5 is 19, minus 8 is 11, plus 15 is 26. It had to come out that way. In order for us to say that the original expression simplifies to 4x plus 2y, that means the two expressions left and right side of the equal sign are the same no matter what the x's and y's are. So let's just finish this up, and this will be a somewhat short video. This is all we're going to do is these 8 expressions, the first 4, and now these new 4. And we won't bother showing that they're the same for a particular value of x, and we won't bother saying what the answer is not. We'll just come up with the answers. Add the x terms. We've got negative 6x plus 2x, negative 4x, right? In the same way that negative 6 plus 2 is negative 4, negative 6x plus 2x is negative 4x. And then we have negative y minus 3y. Remember, this is negative 1y. Negative 1y minus 3y is negative 4y. So there's the simplified version of expression number 2. And number 3, we have negative 6x minus 2x. That's negative 8x. And looking at the y terms, we have y plus 3y. Y plus 3y is 4y. Y is 1y. 1y plus 3y is 4y. 1 apple plus 3 apples is 4 apples. We're adding apples and apples there, which is nice. Okay, so this is 4y plus 4y. And the final one, we have a 6x and a 2x, both positive, so that's 8x. And then y minus 3y. 1y minus 3y, that's negative 2y. I will give you a little bit of practice with these and then quiz you pretty soon. This is an easy thing. Watch these two videos, the first one, and now this continuation. As much as you want, pause, make sure you agree with and fully understand everything that's involved here, and it will be part of your long-term memory of math, because I can promise you that between now and the end of your school math careers, whether it's 12th grade or even into college, you're going to be combining like terms dozens or hundreds of times. You never know when it'll be necessary to do that, and you now know how to do it. So long, 7th graders.